All right, how's everybody doing this morning? Appreciate you guys taking the time to come and hang out. Got a little bit of time left. We'll give a minute or two for folks to jump on in. But hope you guys are enjoying the week. I know it's supposed to get cold here in Colorado this week. Good chance to test that insulation and air barrier, right? Um, and yeah, I know it's a holiday weekend as well. Hope you guys are getting out and doing something fun. I got out and did a little ice fishing with a buddy of mine last weekend, and I think we're gonna try and get out again, but it's gonna be frigid out there. There's no getting around it. So we'll give it just a minute or two longer here. We're pretty close to 8 o'clock. Yeah, we're at 8 actually, aren't we? All right. Well, we'll go ahead and jump in and get started. So first things first, I believe I have the chat set up for everybody so you guys can jump in with any questions, anything like that. I know it's early today, so if you have a question that you want to like stop on a slide or something, feel free to put like, pause or go back a slide or something like that if you want to like try and highlight a question. But otherwise, today we are talking about our next step in the commercial inspection series, which is focused on air barriers. So last time we spoken on insulation, which is our first real component that helps us determine what kind of thermal envelope we have, right? Well, air barriers is that next component, and the best way I can put it, and I'm really going to reiterate this a lot, is they are like buddy cop partners. They are, Jackie Chan and Chris Tucker in Rush Hour. They only work together. And so, I really want to emphasize the continuity and all the rest that we're going to keep trying to get to because that's one of the things that conceptually can be a little tricky about the air barrier is that it's supposed to work to encapsulate the insulation, it needs to be on all sides, and we're really going to try and highlight that today. So with that, thanks a lot again for being here. My name's Andre Hayen. I'm looking forward to taking you through this today. And if you have any questions at all, feel free to toss them in the chat and we'll try and get to them either during the presentation or at the end if I miss anything or have to come back and circle back to something. So as always, we start out at the same place in this conversation, which is we need to have that conversation about whether or not this is going to be a commercial job. And remember that that commercial versus residential definition just looks a little bit different in the energy code. So for commercial, we just say anything that's not defined as residential. Basically, go to the residential definition. That's what's going to help you figure that out. And so what we say on the residential definition is, hey, you can have an apartment building, you can have an R2, as long as it's 3 stories or less, it's still considered residential. So even though I'm bringing the IBC out to that code, out for the code book for that inspection, through the process, I'd still be switching over to the IECC for the residential section when that came up. And that 3 stories is the important threshold to make there. So just want to always keep in mind to make sure we're using the right requirements in the right places. So what about mixed occupancies? Well, mixed occupancies work in that same sort of mindset that the residential section will be held to the residential code, provided it fits all the parameters, 3 stories or less above grade plane, all that good stuff. And then a commercial section would be treated commercially. So one of the ways that you might deal with a podium style building, kind of like what we have in the picture here with this 1 story of commercial and then a couple of stories of residential, might be a mixed com check and res check. So you might end up with 2 reports, one showing no roof, one showing no floor. Now, this is obviously when we get into trade-offs, which is what we're going to talk about next. And I'm kind of not speeding through this, but this is the foundational stuff that we covered last time. And, we're always going to touch on this to meet everybody where they're at if this is the first time joining us. But this is that foundational knowledge that we're going to try and just kind of highlight each time for repetition. But I think you guys have gotten down pat at this point. So yeah, this is one of the strategies that might be used is, okay, we're going to use the com check, res check method. We're going to do a little bit of trading off. And the way that we're going to demonstrate total compliance is we're going to show no floor on the residential section, right? I might have 2 stories of residential. Well, that no longer has a floor and the commercial section no longer has a roof, right? So the roof would start for the commercial section at the floor line of the residential. And the thermal envelope, remember, is exterior oriented only. So what we're trying to do, well, I shouldn't say always, because you can compartmentalize a building under the right circumstances, but it's between interior and exterior, conditioned space and non-conditioned space typically, right? And so when I say that, the building is one entire shell, according to the energy code, right? From its slab and foundation up through its walls, over its roof, and back down. There's no interstitial or intermediary spaces that's being compartmentalized in that sort of fashion. So the separation, even though we might have that 3 hour separation between the commercial and the residential, that's not impacting the thermal envelope, and we don't want to confuse those, right? So like I said, we're going to highlight some of the other basic sort of concepts associated with this. Another major component being our compliance paths, right? That's where we always want to get started. Do I know what type of project this is? Okay, it's prescriptive. We already talked about last time how the prescriptive method has the R values that we'll go to. If we go to the U factor, C factor, F factor, we're going to be using that ASHRAE Book of Fundamentals to get those, that bit of information. And the reason I bring this up now is because, hey, we've got a couple of these, like the total building performance, right? That can allow trade-offs on some items. That can include things like how tight your building is. And so this will have a report that's supposed to be inspected too. That's going to be a little bit different than using our prescriptive method and coming right out of the code book. So just as a reminder for you that there are a lot of ways to look at these problems. And so it really depends on which compliance path you have. So without that information, it becomes really hard to make sure that, hey, do I go off my plans? Should I have an additional report? What information should I have? And hopefully this is one of those moments where we're aligning the expectations that our inspectors are, they're going out in the field and they're trying to set with that contractor or that developer early on in the process. And hopefully that's aligning with our plan review process. So we know that what the information is that we're supposed to be getting out there is accurate and reflective of those expectations. I've got everything I need to get the job going. And I know for some places, energy review isn't one of those things that happens, so that happens in the field. All the more reason to go through and check, okay, do I have my compliance path? Do I know what sort of report is supposed to be associated with this? So, we've started talking about this kind of closes this section on the building envelope as a whole for this series, right? So we started with our insulation. We started with the idea that, hey, we're going to depict the thermal envelope. We're going to figure out where that insulation needs to be, and we're going to use it to separate conditioned and unconditioned spaces. Well, the next steps in that is in order to achieve that level of thermal resistance, we have to control the air movement. And that's what air barriers are all about. So that can come through our air barriers, our glazing, and then our sealing, right? And that can happen at any of these penetrations. So basically, we spend a time building a nice insulated, thermally protected box. And when we do that effectively, then we have to put a bunch of holes in it. We have to put windows in it. We have to put doors in it because no one wants to live in a box with one door. And we wouldn't allow somebody to anyway. For a commercial building, we're going to have multiple means of egress. And I'll talk a little bit about how commercial buildings especially are some of the most tricky when it comes to this because we have instances where we have multiple different air barriers necessary. We have refrigerated areas, we have loading docks, we have things that complicate this quite a bit, right? But ultimately, what we're trying to do is create a cohesive and continuous air barrier that's going to follow our insulation and keep the cold air out, the warm air in as we heat it, and then vice versa when we switch that to the cooling in the summer months. So we're going to try and use that to our advantage. So what we like to say around here is we like to try to break the law of thermodynamics, specifically the second law of thermodynamics. So heat always wants to move to cold, those things want to normalize, and that is the function that we are providing when we provide a cohesive insulation and air barrier together. So let's get into it. The first thing I want to highlight for you is your toolkit. If you're going out there and you're hearing from somebody, hey, I've never heard that I need to provide details on air barriers. What are you talking about? I don't need to give you this. Well, here it is right here in writing that if it's not on the plans or it's something that you need further information on, right here in item 13 on 103.2, C103.2, we have this specific item called out that we're going to provide air barrier and air sealing details, right? So air barrier is going to tell us what assembly we're going to use, what materials we're going to use, and we're going to use that cohesively around this outside of the building, right? It's basically the same thing as, hey, this is how we're going to sheathe this house. Then we're going to worry about the flashing and the penetrations and things like that, and that's our air sealing details. So in a very similar vein is the way to kind of think about that and ask for that information of can I seal this penetration, or can I align the requirements of this assembly you want to use for your air barrier based on the information that you have provided, or do I need more stuff? Do I need manufacturer specs? Things like that. And we'll talk about some instances where that's going to be really necessary. So why is this more complicated in commercial construction? Well, we already talked about a few of those things, right? One of those major items is warehouses with loading docks, right? We have areas that are expressly open to the outdoors. And so we can see in some places in the code where when those areas are like semi-heated, for instance, we've got requirements to try and have those loading docks with seals that'll fit around the tractor trailers, right? That's one of those places where we know that air sealing and that continuity of that air sealing really can make a difference for the heating and cooling costs associated with that building. But having areas like this that are semi-heated, that doesn't happen in residential construction like that, right? We have walk-in coolers and refrigerators. Those have their own independent requirements as well. We've got areas of excessive heat, like server rooms and things like that, where we might need to be cooling substantially more, and we might want to isolate that area from the rest of the building. A lot of restaurants now have roll-up doors or things like that because, post-COVID, they had that outdoor seating, and they really want to keep that. And so they've integrated that into the rest of their business model where that feels like part of the restaurant now, right? We have empty businesses as well. We have cool areas that don't get used. We also have changes of use and occupancy, right? So we have a space that was unheated in an existing building that's now going to be made to be heated because now it's part of a use that's going to require that and maybe is open to the public. So we just have a lot of these considerations. I imagine you guys can probably come up with a whole lot more that complicate this for commercial construction, make it more difficult to achieve. So, air leakage, right? I'm not going to spend too much time on this because we basically have our testing requirements, and I know it's not necessarily a required field item that gets looked at. That's typically something that comes in more in the office. But I just want to remind everybody that everyone's trying to pass this test at this point. And there's a lot of different ways to do it now. There's different rates in the 21 that you can use. You can use CFM per square foot as opposed to air changes per hour. And we can definitely get into the nitty-gritty on the testing requirements associated with that down the road. But I just kind of want to make everybody aware that, hey, in the 21, there's a couple of little metrics that change, things like that. But ultimately, the testing requirement is a big impetus for these companies, these developers, these contractors to want to get this right. Because the last thing that anyone wants to find out all the way down the road on their job is, oops, we did not get what we were supposed to with our test. Our building's too leaky, and now we have to go around trying to seal it. And it's going to be more and more difficult. And hopefully, they're picking an approach with the air barrier product that they want to use that's going to be effective and help them meet that goal. But that's one of those places where I think if we do good inspections and we visually verify that the sealing's happening and things like that, it really reduces the propensity for them to fail and reduces the places where they're going to have to look if they do fail and they have to come back and do some additional testing or fixing in order to be able to pass that test. So just a reminder for you without getting too deep into the requirements associated with that. Yep, so not exactly as cut and dry as it appears, and definitely something with some depth that we can get into. But that being said, let's talk about air barrier construction for itself. And the one word that I really want to highlight here is continuous. If it's discontinuous in some place, that means that we have air infiltration in areas. And if we have air infiltration, then the insulation's not able to do its job, and the entire premise of so much of what we work on when it comes to the energy code starts and ends with a thermal envelope. And like I said, this is buddy cop territory. If these two aren't tied together, then they can't do their job effectively. So remember that that's supposed to travel through all joints and assemblies as well. So if you have dissimilar assemblies, how are we going to make those align to make sure that we have a continuous air barrier as we touch those? That's going to require air sealing. That might require a specific treatment at a specific joint. And so dissimilar materials or areas of change of elevation, things like that, it's not a surprise that those are sometimes the most difficult areas in construction generally, and certainly for aligning those air barrier requirements as well. So here we have an example of exactly that, right? We have the steel frame wall up here. Looks like we're going to maybe have, dens on the outside or something like that. But here we're abutting masonry construction. And so the masonry construction, as we'll talk about and we'll find out later, is an assembly that can meet the requirements of an air barrier. But right here, we are going to have a joint that's going to require some sort of treatment to make sure we have that continuity. So just to keep you guys, keep that in mind, we have those instances of dissimilar materials that occur all the time. Architecturally, it's very pleasing. I think it's something a lot of designers like to use. And then simultaneously, it is one of those things that we have to worry about, and a little bit of prudent planning can go a long way in identifying that during your inspections. right? Our joints and seams shall be sealed for the changes in materials. That's isolated in the section 2, and we're really starting to highlight that now. We also talk a little bit here about the durability. And I've got some pictures later on that really show this with, some gusto. But yeah, an air barrier is only as useful as it is durable. If it tears apart during the regular wear and tear of the building, then we're getting that air infiltration. That's how you end up with that dusty, musty, moldy insulation because we're getting air intrusion. And if air's getting in, it's carrying all the other things that air carries. Smoke, if you're, in California or in wildfire country like here in Colorado, that's one of the first things that you can notice is that smell of, hey, we have wildfires and it smells like it outside. But it's also carrying dust, it's carrying moisture, it's carrying all of those things that potentially degrade a building over its lifetime. So this is where it really pays dividends on the inspection process, and you guys are doing fantastic work to try and achieve that level of continuity. Here's an example of, I think a really thoughtful, sort of line of work here where you can tell somebody took some pride and spent the time to try and do the best job they could sealing this existing brick with this new exterior insulation that's being used to try and achieve a cohesive seal, though they have dissimilar materials. And it's one of those things that you just want to keep in mind. These are the places, the joints and things, that's always places for leakage, right? Water leakage, things like that. It's no different if you're conducting that air barrier inspection, that this is the place to look for. So now we get to penetrations, and now we're getting into that tie between the air barrier itself and the air sealing details. And I love this picture. I know a lot of people that have been with us and seen some of our previous classes have seen this picture before, and I think it's fantastic because you can tell there was prudent planning. You have flashing kits that are set up to accept these, and then we have a miss. And I know this question's been asked, so I'll save it for this morning. It's early. I'm going to give people a break. This right here, being an operable window, required the movement of this pipe far enough away that it wasn't going to impinge on the ability to use that operable window. Well, right there, the planning that was associated with that flashing kit is now kind of useless, right? And now we've got multiple open penetrations and something we now have to figure out a field fix to be able to seal. So this is one of those places that we really want to, encourage folks to take the time, pay attention to, and look for any of those opportunities to say like, oh, wait a minute here, if this change came in and you decided to make that an operable window, change the floor plan in some capacity, and now that's going to have to move, how's that going to affect this? That's one of those items that I think pays dividends. I'm really big on the concept that good inspections save time and money for everyone associated with the job, right? From the building owner or the homeowner to the developer, the contractor. Good inspections can catch those things before they occur. And these are some of the conversations I think that kind of help facilitate that. And I think this picture is just a fantastic reminder of that diligence paying that dividend. So here you have it all highlighted for you, each one of those, and the missing flashing kits. And then we still have penetration right there. So we got a lot of stuff to fix on this that'll have to be figured out in the field, and a lot of unfun taping to do from a cherry picker or a man lift to try and figure out how they're going to be able to seal that up if they're trying to use that Tyvek on the outside. And same kind of thing when we're thinking about our interior plumbing here, we're penetrating through this deck and same exact thing. We're worried about making sure that we have proper sealing. How do you think they did here? I think that they might have left something to be desired in a few places. And how's that going to affect the use of that building over its lifetime? So the next item that we have from our commercial definition of our air barrier is sealing required for sprinklers. And now here's the thing, you can't caulk it, right? Those escutcheons need to be tightly cut and fit. And here we have obviously a little bit of a miss. You can see a little bit of black around this escutcheon where they probably tried pretty hard but missed. And so you think about that and you think about a large commercial building with a really robust sprinkler system. Think about, like an eye occupancy right there, right? And you have 50 of these. and all of them have that little bit of leakage. How much does that add up to when they go ahead and try and do their test if they're using that drywall as their air barrier, right? How's that going to adversely affect the ability for that building to perform over that lifetime there? So you can't caulk it, you can't seal it in that capacity. We definitely encourage people to reach out and ask for the manufacturer sealing instructions from the sprinklers. Typically, that isn't always available or isn't always the case because Hope tells a great story of this being brought up during the code hearings and basically being fought for, like, hey, we need to get this in, we need to get this in the code. And then once it was added, it was, well, no one really asked for them, so we're not going to worry about it. The building seemed to be passing without it because the original intention was to just make sprinkler systems exempt from the sealing requirements. And obviously, that doesn't really work when it comes to testing the building. You can't exactly tell where that air is exchanged or coming from. And so this had to get added in, but all at the same time, you want to make sure that doing what you can to encourage people to, cut tightly to these, plan for these effectively. And if you see caulks or sealant there, that is a big no-no, right? Because then that discussion might not pop off. It might not do its job the way that it's supposed to. Recessed lighting fixtures, right? That's going to be our sealed boxes here to make sure that they were designed to be able to, accept that. You got that foam rubber seal right here. So we're making sure that they're tested for proper use with that. And we see that more and more with the more and more of our electrical components, right? Our boxes, things like that, can either be, NEMA certified for that exact same thing, or, they can be hand sealed, hand foamed. And likewise with our recessed lighting fixtures, we want to make sure that they're designed for exactly what they're supposed to. They're IC rated if necessary, all that good stuff. So what I'm really trying to drive home about this is that air barrier is part of a system, right? Air barriers work in terms of systems. So you're going to have the stuff that's going to cover the vast majority of the build, right? Cover over the walls, things like that. That can be things like Tyvek, that can be zip systems, that can be Gypboard, that can be a number of different things. But it's always a system because it always has to get glued, taped, there's other materials that have to work together with whatever that original air barrier material is. And then we have to worry about our air sealing details. So every time we're going to have penetrations, we're going to have things that require some sort of specialty consideration. And so that's what I mean by a system. And the whole purpose is to control that airflow. And that controlling that airflow between certain spaces not only, helps our energy bills, it can compartmentalize things in the instance of a fire, right? Now, all of a sudden, that smoke, that hot gas, isn't instantly transferring to that next space. So it's a life safety imperative just as much as it is part of that IECC saving energy component as well. And so this is why I think air barriers are kind of special in the energy code. It's one of those places that I think a lot of firefighters support. I think a lot of code officials that have seen the impact of a good air barrier. In residential construction, that can typically be like that garage, that living space over the garage, getting that full seal and encapsulated, not only because the garage is cold, but then if there's a fire started in the garage, that gas isn't directly, ventilating or infiltrating into that living space, maybe that bedroom or maybe that office or something like that. So air barriers, not only save energy, they save lives. And so just to really drive that point home, remember insulation is like this little fleece right here, this fleece jacket. It doesn't have a shell like this one right here, and that's going to have a significant impact in the way that it works in the real world. So the insulation can trap pockets of air, but who's heard of wind washing or air scrubbing on insulation, right? That means that air is able to pass over it and basically pull all of that trapped air out, and now it gets filled with new air. And so that's why this jacket is perfectly fine if it's like September. But this weekend, I wouldn't settle for anything less than this guy over here, right? So that wind shell, that windbreaker is going to help stop that scrubbing of air and make sure that this works together. And so that's why I say these two are, partners in a buddy cop film. They are tied together inexorably. And if you want good insulation, you need a good air barrier, and good air sealing is going to help create those dead pockets of air that gets trapped and lets the insulation do its job effectively. So these two are really useful when they get to work together. So let's talk about materials. The materials are actually itemized in the commercial section, which is different from the residential. So if I have any inspectors here that have been doing residential energy inspections for a while and might be coming over to the commercial side, one thing that you can look for in that section in C4025121 is you actually get a list of specific materials that tells you exactly what you can and can't use. And we can kind of run through them here, but here we have plywood and OSB. We've got our minimum thicknesses here. We've got extruded polystyrene, no less than a half inch. And you notice on these, the manufacturers are going to have some requirements telling you how to seal, with what materials, all of that good stuff. Foil-backed polyiso, again, can be a method in order to achieve this. Closed cell spray foam, minimum 1.5 inches in depth. And that's going to help get to that point where it's got the resistance of being an air barrier. It's got a lack of permeability. So we had a good conversation last year in a class that I'll probably bring forward again about permeability and perms and how that whole thing works. And so if you want to get into a deep dive about the materials, I think we'll probably bring that back sometime later in the year. Open cell spray foam, same thing, but you have to get to 4.5 inches. So if you are spraying in on that 2x4 wall, even a 4-inch steel stud wall, that's not going to be enough, right? So just one thing to kind of keep in mind and always remember is that difference between open cell and closed cell. And if your plans are a little vague about it, that's one place where you really want to get some clarity, because if that's supposed to be both part of the insulation quality and your air barrier, using the wrong material in the wrong place can have a devastating, impact on the ability for that building to perform. We've got our gyp boards. We have both interior, exterior gyp, and then cement board as well. And then we've got a series of roofing membranes here. And one thing that I want to highlight, it's not that there are two 11s in the code, but there is a difference between the 21 and the 15 and 18. So it used to be fully adhered single ply membranes on top, right? For our roof at the 2015 and the 2018 editions. But then it just got changed to single ply roof membrane, meaning that your mechanically fastened TPO or EPDM can be a method to achieve that without worrying about it. So just to give you guys some peace of mind there. I think it's a good one by reference in case you have somebody that is on the 18 and is saying, hey, I've got everything I need here. Just know that the 21 does see that differently. And if it was an alternate means, I think that's a very easy one to kind of crowbar in there and say, yeah, the newest code does recognize that. So that's a valid method. You can also use your stucco, right? And stucco is also stuccos, plasters, because they have the two paper system, right? Where you're going to have typically your water resistive barrier and your bond break there. You do have a system that is pretty robust in terms of trying to create that separation using those building papers or using those materials as well to try and seal that in, which will actually bring us to kind of a conversation here in a little bit about things like Tyvek. Precast concrete can also be a method in order to achieve this. So there's a lot of different ways of being able to get to a place where your initial material is going to meet that. And obviously tilt ups, things like that are typical to our commercial construction and align with that issue of our dissimilar materials. So like that first one that we saw that had masonry, well, if it was cast in place wall or a precast wall that we're going to tilt up, that could achieve that. And then we're just worried about that joint with our steel studs and whatever, siding or whatever we're going to run to make that a little bit more architecturally interesting. But this is a nice place to look at and say, okay, these are the materials that can be used as an air barrier. Fully grouted concrete masonry and sheet steel or aluminum. And this is one that I think always gets some people, especially on some of these, metal buildings where that sheet aluminum, they're worried about, well, don't you have to lap it and seal it? Shouldn't there be like butyl tape or something? Shouldn't there be something that requires that? Well, the ribbing on those sheets and the attachment with the lap that's required from the manufacturer meets that requirement of saying that that seal is good enough. So when it's screwed off properly, when it's installed per manufacturer spec, it's not going to require anything in addition to like a caulking or something like that. I've heard that question come up a lot, and I think it's just an important one to recognize. So, here's the list in total for you. And I think it's an awesome place to look at both for the commercial section. And then if you do have, questions in the residential section, using this list, I think is totally valid. We also have assemblies, and these assemblies can meet this requirement. So it gives your perm rating that's anticipated based on the conditions of this assembly. So we have our concrete masonry walls, either filled with block filler or two applications of paint. We have masonry walls, 4 inches or more, and we have our stucco plaster not less than 1/2 inch. So right there, we have a list of assemblies, not just the materials. And so the next step, in my opinion, or where we go from here, is, what materials aren't listed? What comes to mind for you guys? I know we've already talked about Tyvek. What other materials have you run into in the field that, you would say, well, this does meet the requirements of an air barrier, per the manufacturer? Zip systems is another one that comes to mind, right? Taped off properly and sealed, all of that good stuff. There are a litany of good products that you can use out there that are viable and useful, but they're sometimes going to have some differences in the way that they're installed. So, for instance, the Tyvek does have a water resistive series of requirements where it's going to say, hey, it's the water resistive barrier. You just have to lap it this much. You should tape here. You should tape this. Then, if you're going to use it as the air barrier, it's going to have specific recommendations on how to tape all sides of things to make sure that all your joints are perfectly are lapped better, are perfectly sealed, that sort of thing, because it's performing a different function at that point. It's not just wicking that water away from the foundation, from the wall assembly, and trying to make sure it gets to the drainage plane, right? It's really trying to fully stop any airflow and rely on its non-permeability in order to be able to do that. So it's just a reminder for you that there are materials tested in accordance with the requirements to be able to be an air barrier that aren't going to be listed there. And so that really brings me to, this point, like I was saying, water resistive barriers, are going to be different from our air barriers, and sometimes they're used interchangeably in the field. Down the line, we'll probably do our working with barriers class where we go through vapor barrier, water resistive barrier, and air barrier. We break each one down and kind of go over those. But there's no getting around the fact that those are sometimes used completely interchangeably on the job site. And that can get a little tricky because, as we're going to talk about with our air sealing, there's often multiple different kind of ways that a job might run to do it, right? They might hire a third party that is all they do is just seal everything. They're going to make sure this building is foamed up properly. They might be part of the insulation company and they're focused on the air sealing details. But I guarantee everybody on this class, everybody on this call has had a job where it's, hey, the plumber's going to seal their stuff, the electrician's going to seal their stuff, the tinner's going to seal their stuff, right? And if they are in disagreement or not speaking the same language about which one's doing which, if one guy thinks that the Tyvek is actually the air barrier and it's not, it's going to be something on the inside of that wall system, or maybe it's the spray foam or things like that. Are they going to seal to the right places? Are they going to treat their joints and their penetrations correctly if they're not recognizing that it's the same material for everybody? So it's just one of those things to point out that speaking the same language and setting that expectation. I had this plans examiner when I first came into working, named Bob. And Bob he was a stern guy. He built churches and houses with his dad, and older fella. I think he retired in his late 70s. And he just always used to say, Andre, words mean things. Every time, Andre, words mean things. So if I was reading the code and I would give something back to him that wasn't, exactly as the definition actually implied, he would say, nope, Andre, words mean things. And I'm not saying anyone has to get that stern, but I think there is a level of paying dividend on that, where making sure that everyone's speaking the same language on this issue, especially if they're sealing their own stuff, can really make a difference. So, what do you guys think of something like this, right? This Tyvek's up. We got a lot of puckering on it, and we've got places where it's kind of tacked up. We've got corners where it's a little bit rough here. And, do you think this can do the job as an air barrier? And can it do it effectively enough that, this isn't going to deteriorate over the lifetime of the building? You know? Just one of those things that can come up. Did they follow the installation instructions specifically for Tyvek for an air barrier? So we've gone over our assemblies. We've talked about some of the places where that can end up. So what's the first thing that you need to know when you jump into your plans, when you jump onto the job site, when we start having this conversation? Well, we kind of hit on it when we talked about the other trades and interacting with them, right? Because one of the first things is what is the material or the assembly? Because we have multiple things that can qualify for it, right? And some of these are used in conjunction with each other, right? So we might have a system that's going to get stucco and simultaneously might have polyiso on the inside of the wall. Hey, which one are we going to use for our air barrier? And that's one of the things that the design professional really does owe you due to 103.2. C 103.2 tells you, hey, the air barrier has to be specified and the sealing details, so we know we're sealing back to that air barrier assembly. So identifying that for you is a key component to being successful about it, because if you have to guess, then you're in the same boat as everybody else. Everyone else on that job site also has to guess to a degree of, what is that material that the design professional thought ought to be there? And why should it not be an afterthought? Why should it not? Well, if that's that foil-faced polyiso or, any other material that might be on the inside while people are working, if it's not protected, then we get damage. And if we get damage in that foil, that can't do its job anymore, right? And all of a sudden, we've got multiple places where we're going to get, leaking air, and that's going to degrade the opportunity for that building to be able to pass that test down the road. Well, got a bunch highlighted for you here. I don't see too many more. I don't think I see anything more, but you can tell, this was not a consideration, and maybe this wasn't passed along to the folks doing the work on this that, hey, this needs to be fully continuous. Any, cuts, breaks need to get joint treated, need to get fixed and sealed, all of that good stuff. Maybe that information isn't getting passed along. And so by the time it gets to inspection, it's like, ooh, this isn't gonna work. What do we think about this one, guys? How did we do today? We got a nice tight seal to the bottom of the pan deck here. We've got pretty tight cuts to our steel. Looks like they're trying pretty hard to seal this thing up. What do you guys think? Oh, oh, Hi everyone. I am so sorry if you guys were locked out for some reason. Seemed to be a broadcast issue with Zoom here, and I'm not sure why. I hope you guys can hear me at this point. Looks like we had the webinar going, and then it gave sort of an update that a few folks were kept out of the meeting for some reason. I'm not exactly sure why that happened. So I sincerely apologize for anyone that was having a hard time with that. And so, we'll kind of pick up where we were. We were talking about, a series of air barrier related products here. I'll go back a few steps here. And basically, the first thing to know during the inspection process is, what material or assembly is actually being used and identified on the plans. Because if that isn't identified properly and isn't made clear, then it's really tough to make that determination of exactly what material you should be sealing to, what should your air sealing details basically functionally get to, and why it can't be an afterthought. So right here we have a perfect example of the multiple tears. I'll highlight these for you. The multiple tears in this material on the exterior here, and how that's going to adversely affect the ability for this wall to perform and meet its infiltration goals. And so if this isn't identified, cohesively to not just the plans, but to the folks actually doing the work and the install that, hey, that's what we protect, that's what needs to get taped off, then we are going to run into some major issues with the effectiveness of that air barrier assembly. And so right here, guys, what do we think about this? It looks like we have a pretty decent seal on the other underside of this pan deck here. We've got, looks like a decent tape job. I don't see any seams in our exterior insulation that aren't treated. And that is what we're looking for, especially when we touch those areas of sort of building joints or dissimilar materials like we've been talking about. Because if you touch that joint, you have to make sure that there is some manufacturer, some detail of how we're going to be able to make sure that that's going to work. And we run into, on the commercial side, like we've been talking about, we run into dissimilar materials all of the time. We had those slides earlier showing a CMU wall abutting a steel frame wall. We're going to have to worry about how that joint's going to have to match up and, what's going to happen with that. Here is a fantastic one, as far as showing the alignment between the air sealing details and, this, I'm really hoping, this photo was taken at a place where, no one was saying that, hey, this is done. When we get our photos, it's not necessarily always for an inspection, so to speak. But we can tell that if this was getting papered over right now, and we have these gaps where we started over here, then we didn't touch over here. We don't have sheathing on this side. It's surprising me that they're papering this at all at this point. It looks like the sheathing is on the inside of that wall now, based on what I see. And yeah, I mean, yeah, this is going to get tricky. And all of these penetrations out here, you can see that it's kind of rough cut around the Tyvek. If the Tyvek is supposed to provide that material, the Tyvek is supposed to provide that air barrier. This is going to be a difficult joint to treat, right? And this penetration is going to be difficult. So, just one of those places again where a little bit of discussion and kind of future planning can really pay a large dividend on the process. Now, how about this one? What do you guys think there? And that is an absolutely tough one. Um, this you can tell, from the layout over here, they missed their anchor bolts. This entire wall looks like it's a good 5 inches in from where it's supposed to be. And that's why they're now centered on these pipes. And I have no idea how you're going to worry about treating that joint. That is one of those places where by the time you get there, I don't quite know how you fix it. But, one of those things that, yeah, the fact that this happened in real life, to me says, yeah, it can happen again. So here we have, in my mind, a really good, solid plan here. Every kicker off this wall, has been taped in. You can tell that there's no white showing. The foil here is being protected, being used properly, and we don't see a whole lot of tears here. None at all, really. I think all the seams look pretty clean. It's a good example of trying to make sure that there's continuity on that item. So what do we think here with the DENS glass? Can DENS glass be part of our air barrier system? Well, if we think back a little bit, the answer to that should be a pretty clear yes, because cement board and gyp boards are automatically, not automatically, they have to be the right thickness and all of that stuff, but they are listed in C402 for your materials, right? So that's going to allow us to be able to use some of these even if it's not expressly enumerated as product. Here we have this getting sealed up, and it looks like there was one little section right here that maybe got missed on this one, but that kind of thing is exactly why we're around, is to go, okay, it looks like it was 4:30 on Friday, and let's make sure that we head back to it and make sure it gets sealed off, right? We got a few places where, you can definitely tell we've got this horizontal seam right here that didn't get taped, it looks like. What do we think about this one, guys? This is an interesting one. Do we see any discontinuity with the air barrier? We see insulation board, and we see tape, 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 and then we got this vertical guy right here, and we have it wrapped with Tyvek, and we don't have continuous insulation on the exterior here, and that might have been a requirement at that point. Maybe that was supposed to get furred around, and that didn't happen. So we do have a little bit of tape falling down in the corner here. And then, you do wonder, did this joint over here with this brick, get treated properly? Is that adequate the way that it was done? And what do we think on this guy? Well, the softening underneath here and making sure that this is encapsulated, that's a key component right there. What about our penetrations over here? Those look a little haphazard, right? I don't see any flashing kit around it. I don't see any tape. You got some examples here of some places where you may want to take a second look or deal with it early, try and have a plan for it early, especially if you get that change order where you say, okay, we couldn't take this pipe out this way. We had an obstruction we didn't plan for. We're going to move it and take it out over here. Cool. Do you have a plan for instead of penetrating where you were going to, do you have a different plan with a different flashing kit? Do you need one? Here we're sealing that guy off. But, this is a perfect example that the alignment of those panels doesn't easily lend itself to an easy seal. Building that tightly, having that pride in the work to make sure that everything is as tight and rigid as you can get it, good fits on all your joints there. This just makes it harder to be effective in the future there as you try and work towards sealing that up and getting that ready for testing. And then over here, we have our cantilever, we also have our ceiling up here. How do we think we did? Looks like we've got all the windows pretty well. But it looks like, we haven't addressed this yet, and we want to make sure that there's a good plan associated, with an area like this, because man, those cantilevers can get cold. And depending on what kind of business this is or what kind of building this is, if this is an apartment building, the stack of windows over here, it doesn't tell me necessarily that there's plumbing out there, but it's one of those things that it's like, yeah, that could easily be a place where someone wants to put a sink and have a view and that sort of thing while they do the dishes. And, those are oftentimes the places that get missed are those cantilevers, those floor systems, that extend over the exterior there, that don't get that level of consideration. And what do we think about this guy? Are we getting the seal that we need? All in all, that's looking fairly decent. And then, yeah, what do you guys think over here? I mean, this one, what do you think's missing over here? What do you think the problem is? Because I think this is a perfect example on these steel buildings. It looks like we have a greenhouse on the inside of here. We've got this penetration coming through. And here's it highlighted for you here. And yeah, we got a round ring and you can see the black, you can see the gap there between the cut and the panel and where they're flashing out this penetration. And I mean, first of all, water's going to intrude in there, right? It's going to run down that ribbed panel and find its way back. But obviously, this is not a good seal. And we already talked about how those steel or aluminum panels, just when installed per manufacturer specs with the required lap, are going to meet that requirement of being an air barrier. More photos of Dunsglass here. Let's see if we can highlight that a little bit. For this bump out, do we have the proper sealing associated with this? Our this is one of those places where I think commercial really has that burden on them because you get so many different jogs, you get so many attempts to make what's otherwise kind of a boxy building more architecturally pleasing. And so you get dissimilar siding materials, you get these architectural bump outs and changes and things, and you get a lot of dissimilar materials. And these are the kind of pitfalls or difficulties I think most associated with that continuity of air barrier on the commercial setting. Here again, exactly what we're talking about. We have that dissimilar material problem. We have our masonry on the sides here. And are we getting that seal? We also have our roofing membranes. Remember, as we talked about earlier, the 15 and the 18 code used to require that fully adhered. Then by the 21, we jump over to a place where it's no longer fully adhered. It's just single ply membrane. So mechanically fastened membrane can fit that bill according to the 21. And for those of you that might run into that issue where you have to take a deeper look at that, that is one of those things that, you can say, hey, it's an alternate method or material, but, it's showcased in the 21 code. So it's probably an easy adjustment to be able to make if you have a project that you have to worry about like that. But this is also one of those things that we want to make sure we understand where the air barrier is going to be. And if we have areas of dissimilar materials, maybe we have two different air barrier assemblies as well. Here's a great example of that joint over to the side here, where we can see exposed iron, and I don't think that there was a plan for that joint treatment. Now, this could be an addition on this side, and then they're just cracking this open for some siding work. It's totally possible, but still, we have to worry about trying to get some level of continuity out of that if possible. And again, air barriers tend to work best, like I've said, air barriers work with our insulation like a buddy cop film. They are Jackie Chan and Chris Tucker in Rush Hour, right? They work when they're together. And one of the things that all of this is predicated on is good construction quality. The tighter the construction quality, the easier it is for the insulation to have the right cavity size and space to be able to fill, right? It's got tighter joints, which means that the sealing abilities of that particular sealant material can be planned for and used, right? No one wants to run into that circumstance where, hey, the sealant that I have is only good to a half inch, and I got 3/4 inch gaps all over this building. That doesn't lend itself to that conversation where you're going to be effective with the materials that are going to be on site. And once again, I'm back to that same idea that a good inspection saves money and time. And that's on behalf of the contractor and on behalf of the homeowner or the business owner, right? They're getting into that building faster, they're getting in at the cost that they predicted, and they don't have surprises like that. And so setting the tone early on at, say, sheathing inspection, if you see things like this, of guys, how are you going to air seal these? Do you have a plan for that? Because you got gaps like this all over, and what kind of impact is that going to have when you try and test? This is another good example of that workmanship issue. Here, we have a clear plan to get a pipe through that hole, and hopefully they didn't drill, a 3-inch hole for a 1-inch pipe. You know, this over here, I don't know how you're going to seal that. That's not going to be easy. You may need to cut that section of seathing out and replace it because there's not a great plan in order to be able to identify that. There might not be any seals associated. I don't think a quick flash is going to solve that problem, no matter how hard you do it. And so this is one of those issues that it goes back to the ability to have that good workmanship. I went out to a job site not that long ago with Hope. And we were touring a series of buildings, and this guy had a really good rule, in my opinion. He basically said, "Look, if you want to drill a hole in my job site, I will only give you a hole saw 2 pipe sizes bigger than what you need. That's it. That's all you get." And so, if you've got a 2-inch pipe, 2.5 is all you get. And so that helps ensure that when they go back to try and seal for any of these, when they have to do any flashing kits or things like that, what they have is going to be effective given the circumstances. So with our air sealing, right, this is one of the places where I think your plan reviewers can really support the work that you're doing in the field. Penetrations like this and having a clear idea of, okay, we're sealing right here. We have continuous bead of canned foam. So we know we're doing this at the floor ceiling line right here, right? And so at this ceiling line, this is going to be where our air barrier is preserved, which tells me that we're probably using the finished ceiling like the gypboard in order to be able to make that seal and make that air barrier. Hopefully, like we talked about, it's already identified in the plan set. It's already telling you what's going on and what's happening. Pipes or vents, same exact thing here. We can see this penetrating through the roof deck, and we've got our seal. Remember that there's a difference between our exterior seals right here for water intrusion, that sort of thing, and then making sure our air barrier is preserved. They aren't always the same. It's a bit like the Tyvek conversation. It can be both, but we just got to make sure that it's identified for the use of both. And this goes back to our conversation about durability, because at the end of the day, if this is an oversized cut on the pipe and then this didn't get treated properly with a quick flash or something that was going to, be able to stand up to that durability question, this opening, eventually the wind just tore this out. and you can tell they've come back and they've taped it a handful of times trying to make this right. But there is no real fixing this at this point, and I imagine that's leaking in a lot of air all the time. That's going to make it difficult for that building over its lifetime to be effective. Same kind of thing if we're trying to penetrate and we're trying to use the drywall ceiling as our opportunity there in order to seal those guys up. We left almost no room over here to get behind this and get a good seal. And that's one of those places where just that prudent planning and that conversation, how are you going to do that? How are you going to do that? Here it is from the backside, and you can tell they tried cutting in some drywall to it, and it's not exactly a tight fit, and there's just nothing that can be done about that. Now it's a matter of, well, my canned foam or something like that. If that's going to be able to seal that pipe correctly, and can it be used in that capacity, right? All of those foams and sealants have a maximum space that they're allowed to fill. Either it's a number of square inches per square foot, or a cavity no greater than X or Y or Z. But yeah, just keep you guys in mind that, hey, all of your foam sealants, things like that, are we prescribing the right thing for the right place? And then here's a perfect example of foam ain't going to do it by itself. This is worrisome of rodent intrusion and things like that. Things can still get into these spaces over here. And this is just unfortunately that idea that, hey, we'll just seal it on the backside and not worry about it. This is what happens, when that's not planned for effectively. And here we have the opposite. Here I think we have some good examples of our quick flash systems getting installed. You can tell there's an adequate amount of distance between these two pipes, so it was planned for that they'd have a little bit of separation in those bays so we could use these effectively without overcrowding them or causing any issues. And I think I mean, this is pretty bad, all things considered, and trying to seal around this box here, how are we going to? This is one of those places where, I remember one of the first inspectors that took me out on a job site basically said, if I have to call your work creative, that's not exactly a compliment. And, this is creative. You got to give it to him on that. And we can see some pipe insulation in here. So it's not like they didn't try to think about it. And yet at the same time, how do you seal this? Is there any good detail or anything that you can use to say that this is going to be an effective seal in this area? I think we've seen line sets like this that, are just, they've just got a little bit of either pookie or sealant, or in this case, it looks like a little bit of grout coming in there to try and seal that guy up. But again, this could be done with pride in your work, and this could be done with a good plan on the outside. Same kind of thing on the CMU. We've talked already about CMU, especially full grout, right? As an assembly, it's already listed in your commercial code, but simultaneously, the penetrations in CMU are one of those places that sometimes gets left out. And this is one of those places where your plan reviewers can really support you on the conversation of saying, hey, I need your air sealing details, including where you're going to penetrate these things. Make sure that we have a plan for how you want to handle that. And again, take you back to this photo. This is one of my favorites because I don't know how to explain this. The entire wall is over about 5 inches from where it's supposed to be. You can see the anchor bolts out here. This pipe was clearly supposed to be in the wall cavity, and now it's exterior to it. And that's not an easy fix by any sense of the word. And that's one of those places where by the time we've already done foundation, by the time we've done underground plumbing, right, all of this was in alignment and planned for. And then I don't know what happened after this, but I don't know how that's an easy fix. Here's what they ended up doing, and I don't know. I don't buy it personally. I don't know how this is going to happen. Um, that's a tricky one. Whereas here we've got, our pipe insulation cut tight, we've got the penetration out, right? We've got a difference in, what people are trying to provide for their workmanship. And, it looks like we've got a little bit of seal around there as well to try and plan for that. And you just want to make sure that you're having that conversation early of how are you going to seal that, especially on those change orders, right? And so one of the things that I kind of wanted to end on with our presentation was just recognizing the fact that, hey, we talked a little bit about the air testing, and I kind of left it off this presentation because it's not necessarily germane to the inspection process. It's more of a back-end closure process. But ultimately, the inspection is helping lend the credence to the success, right? That's going to help people be successful by doing those visual inspections, asking those questions, having those details, making sure they're enforced during the build process and all of that happening. That's going to help ensure that success on that issue. And one of the things that can be used for a additional energy efficiency, right? Because remember, those can be a requirement, can be the increased, or excuse me, the reduced air infiltration. So addressing that, making sure that somebody's got a plan for it, and if this is part of what they're going to do in order to be successful for their project, that they are really being rigorous about this. This is one of the most difficult, in my opinion, means of being able to achieve for such a low leakage rate for CFM per square foot. But can it be done? Yeah, and they're entitled to try and use it as part of the code. So if this is their plan, having that robust conversation early can really pay those dividends. So with that, we're wrapping up. I am sorry again. I didn't know what happened there on the, on the Zoom there. I had some folks in, and then all of a sudden something weird happened. I'm not entirely sure. But in any case, this is recorded. It'll definitely be posted. So if you'd like to go back and you missed any section of it, we'll make sure to get that out there for you. The Colorado Codes line is active. If you want to go ahead and send us any of your questions, please feel free to use it. We're always happy to get your questions and try and help you out in any way possible, and that's through any of the codes listed here. So feel free to use that at your convenience. After this, there will be a short survey. Please take a few moments to fill that out. It really does mean a lot to us. Figure out what we could be doing better. Obviously, a technical difficulty, if you were affected by that, is probably one of the worst things that can happen. So I do apologize for that again. And if you have any questions or would like to see more of this slideshow, let me know. I'll be happy to forward it to you. And with that, my name is Andre Hayen. Thank you so much for joining me today. Really appreciate your time, and I hope you all have a fantastic rest of your Tuesday. Thanks. All right, guys, have a great rest of your day. Take good care.